Welcome to my channel, and let's look at reduced row echelon form of matrices. We had looked at row echelon form of matrices earlier, row echelon form of matrices. Now this time I want to look at reduced row echelon form. This is also known as reduced echelon matrix, reduced echelon form. So you can call it reduced row echelon form or reduced echelon form. That's what we want to look at. And so what we look at first is, when do we say that a matrix is in a reduced row echelon form? So a matrix is said to be in a reduced row echelon form, or precisely as being in reduced echelon form if it fulfills the following properties. That one, it must be in row echelon form. And two, the leading entry in every non-zero row must be a 1, which we shall call the leading one. So the leading element in every non-zero row must be a 1. And then that leading one must be the only non-zero element in its column. That leading one must be the only non-zero element or entry in its column. So that way, then we say that the matrix, if it fulfills these conditions, we say it is in reduced echelon form or in reduced row echelon form. So let's look at example of matrices that are in reduced row echelon form. So the first example is this, and I'm just going through the entries, through the properties. The first property is that every non-zero row has 1 as the leading element. So I have this non-zero row, its leading element or entry is 1. This non-zero row, its leading entry is 1, and this row also has 1 as the leading entry. And notice that this 1 is the only non-zero element in its column. This 1 is also the only non-zero element in its column. And this 1 is also the only non-zero element in its column. The same thing can be observed here. The leading entry in this row is 1. The leading entry in this row is 1. The leading entry in this row is 1. And a row of zeros must be at the bottom. Notice that this 1 is the only non-zero element or entry in this column. The same to this 1, and the same to this 1. So these two matrices are in reduced row echelon form. And these two are also in reduced row echelon form. Because you can see the leading one is here. There's a leading one here, there's a leading one here, there's a leading one here. And these leading ones are the only non-zero elements or entries in their column. And the same applies to this matrix. So this matrix is also in a reduced row echelon form. So that's basically what we'll be trying to achieve, what we will be wanting to achieve every time we are told to reduce the matrix to reduced row echelon form. So let's look at this example. The example says that transform the following matrix to reduced row echelon form. Transform the matrix to reduced row echelon form. Somebody else will have said that transform the matrix to reduced echelon form without the word row. So again, it will still mean the same thing. It will still mean the same thing. Now, so to do that, we look at this matrix and you can see that this first row here is non-zero row. The leading element here is 2. So we make it 1. So we make it 1 by dividing row 1 by 2. So divide row 1 by 2. Because the leading element must be 1. So when I do that, I get 1, a half, and negative 1. So I have achieved what I wanted. I wanted that the leading element should be 1, and I have it. Once I have this leading element as 1, I want it to be the only non-zero entry in this column. So I use it to create a 0 in this position and a 0 in this position. So how do I get a 0 in this position? By taking row 2 and subtracting 3 row 1. Remember, I'm using this leading entry there. I'm using that leading entry. And as I said, whenever you do this, it's always good to show us your elementary row operations. For instance, I've shown my row operation that gives me this matrix. And I'm now showing the operation that will give us this other matrix. So to get a 0 in this position, row 2 minus 3, row 1. What about in this position? Get a 0 there. I will take row 3 minus row 1. So let's do that very fast. 3 minus 3 times 1. This is 0. Negative 3 minus 3 multiplied by half is the same as the same there is 2, and this would be negative 6, negative 3, which is negative 9 out of 2. What about here? Negative 1 minus 3 multiplied by negative 1. Remember, these minuses multiplied will be positive. So I'll have negative 1 plus 4. No, negative 1 plus 3, which is 2. Now, for these other rows, just subtract row 3 minus row 1. So 1 minus 1 is 0. Negative 2 minus a half will be negative 5 over 2. And then 3 minus negative 1 will give me 4. I'm done with this first column. Now I come to this leading entry here. Make it 1. How do I make it 1? By multiplying row 2 times negative 2 over 9. So the entire row 2 multiplied by negative 2 over 9. That gives me 1 here and negative 4 over 9 here. So the other rows, I've left them the way they are. I've only changed this row because I wanted this one to be 1. Once I have this 1, I want it to be the only non-zero element in row 2, in column 2. I want it to be the only non-zero element in column 2. So I want to use it to make a 0 in this position and then a 0 in this position. How do I get a 0 in this position? I get that by taking row 1. And remember, I'm using this leading element. Every time you create a leading element, use it to create zeros elsewhere in the column. So row 1 minus a half of row 2. And to get a 0 in this position, I take row 3 plus 5 out of 2 of row 2. Let's do that. So row 1 minus a half of 1 gives me 0. And then negative 1 minus a half of negative 4 over 9. This is the same as negative 1 plus 4. Let me just say 2 goes here twice. So that I have this should be 2 out of 9. And this is negative. It gives me, what is that? Just a minute. Let me erase this so that it's clear. I want to get a 0 in this position. I've said I multiply this by half and subtract from this. So if I multiply this by half, and subtract from this a half, I'll have a 0. And do the same for this. Negative 1 minus a half of negative 4 over 9. And this should be 2. So I would have negative 1 plus 2 over 9, which is negative 7 over 9. So this is not correct here. It's supposed to be negative 7. Negative 7 over 9. Not negative 1. It's supposed to be negative 7 over 9. Negative 7 over 9. What about, we are done with the first row. Now we come to the second row and create a 0 in this position. And we already said that will be achieved when we take row 3, and then into it add 5 out of 2 of row 2. 5 over 2 of row 2. So let's just do that, because I'm seeing that the first working that I have here is not correct. So let's just work out, and hope you can follow, and then do it later to find out the correct one, because supposing I'm doing something that's not correct, but the procedure is correct. Now, so row 3 is negative 5 over 2, then plus 5 over 2 of 1. And this gives me 0. This 0. What about here? 4 plus 5 over 2 of this, of negative 4 over 9. This will go here twice. So what I'd be having before minus 10 out of 9, which is same as 36 minus 10. That's 26 over 9. And that is this 26 over 9. Then the next thing I want is to create a 1 in this position. That's the next thing I want. You just erase this. Erase this. And you know that we corrected this entry and wrote it as negative 7 over 9. Now we have this, make it 1 by multiplying this row Multiply this row by 9 over 26. So row 3 by 9 over 26. That gives me 1 here. And this remains to be negative 4 over 9. And this is what we changed to be negative 7 over 9. Now I want this one to be the only non-zero element in this column. On this one here, it's 1 of negative 1. It's 1. So I want that one to be the only non-zero entry in this column. So what do I want? I want to multiply the entire row 3. So because I want a 0 in this position, so I would have row 2 plus 4 over 9 of row 3. And then row 1 plus 7 over 9 of row 3. So that will give me a 0 here and another 0 here. So that our final matrix in reduced echelon form would be this. That would be the first final matrix that we say is in a reduced row echelon form. Let's look at another example. An example is transform this matrix to reduced echelon form. And so very fast, now that we know the procedure, we want this one, this leading 1. Unfortunately, it's already a 1. If it would have been something different, we would have created a 1 in this position. But since it's already a 1, we ensure that this becomes 0 and this becomes 0. So how do we do that? By taking row 2 plus row 1, gives me a 0 in this position, and then row 3 minus 5 row 1 gives me a 0 in this position, in this other position. So let's do that. This plus this gives me 0. This plus this gives me negative 1. This plus this gives me negative 4. And then row 3 minus 5 row 1, this 5 minus 5 times 1 gives me 0. And this negative 13 minus 5 minus 3, this will be 15. This 15 added to negative 13 gives me 2. And then we do the same for this and that to get an 8, to get 8 in this position. Now, so we have this matrix. I want this element to be 1. So I multiply row 2 by negative 1. So when I multiply row 2 by negative 1 and leave the other rows the way they are, this becomes positive 1, this becomes positive 4. I have a 1 in the position I wanted. I use it to get a 0 in this position. So to get a 0 in this position, I would have row 3 minus 2 row 2. Row 3 minus 2 row 2. So when I do that, I get a zeros in the last row. And elsewhere I have this. The matrix that we now have, this matrix, is in a reduced row echelon form. This matrix in a reduced row echelon form, or in a reduced echelon form as it was required. Let's do one more example. And the example here is apply elementary row operations to transform the following matrix to reduced row echelon form. Now, so what I've shown here is this. So let me just see what I did here. I have this one. I use it to create a 0 here, a 0 here, a 0 here, a 0 here. So what are my row operations? When you're doing it, ensure that you have enough space here that you can write your row operations above this up. But for me, because my space is not enough, let me write my row operations here. So to get a 0 in this position, I took row 2 minus 2 row 1. And then row 3 minus 3 row 1. And then row 4 minus row 1. And then row 5 minus 2 row 1. So when you do that, this is the matrix you get. This is the matrix you get. Now, so we'll be done with the first column. We now come to this second row, and this is our leading one. We make it 1 by multiplying row 2 by negative 1. Multiplying row 2 by negative 1. And so when that happens, and the other rows are left the way they are, what we get will be this. This is what I get. So you can see now I multiply row 2 by negative 1, and I have this. The other rows, I leave them the way they are. Now, so what next is to use this one that we created to have zeros elsewhere in the column below it. So the most fortunate thing is that we already have a 0 here and another one here. So we're only left with creating a 0 in this position. So to create a 0 in this position, we need row 3 minus row 2. Row 3 minus row 2. So now I take this minus that, I have a 0. This minus that, I have a negative 4. This minus that, I have a negative 2, and so on. So this is now our leading element. We must make it leading 1 by dividing row 3 by negative 4. So when you divide row 3 by negative 4, you'd have 1, a half, 3 out of 2, and then 5 out of 4. So we obtain this matrix. Now, so then the other leading element that we now have on this matrix will be this. And we use it to create zeros elsewhere. It's fortunate that it's already a 1. Otherwise, we would have created it to be 1. Since it's already a 1, we multiply row 2. No, which row is that? 1, 2, 3, 4. Row 4 by 2. Row 4 by 2 and add to row 5 to get a 0 in this position. So row 5 plus 2 row 4 gives us a 0 here. It seems like I repeated these two matrices by just the same. These are repetition. Or maybe there was a negative sign and so I had to remove it. But it's okay because I'm seeing this matrix is a repetition of this. But you go through slowly and see what happened. Now, so when I take what I've just said, because I've said that I would take row 5 plus 2 row 4. When that happens, this element becomes 0 and this also becomes 0. And so we have this matrix in reduced echelon form as required, because we wanted to write that matrix in reduced echelon form. And that is what we've just done. So you go through those workings slowly and see that you get the same results, or if there's a mistake, you can try and rectify. But the procedure is what I've shown you. Thank you.